to Maths and Science Unpacked. In this video, still exploring the major topic number, we want to look at prime numbers, HCF and LCM. What do these mean and what are their relevance in mathematics? Join me on the whiteboard and let's explore this together. So welcome back to our lesson on number. We have been looking at multiples, factors, powers, and roots in our previous lesson, and we are going on to prime factors, HCF, and LCM in this lesson. So please look out for the previous videos. As I said, I've structured the lessons in a way where we build upon the previous one. So we started looking at types of numbers, board mass, multiples, factors, and powers. And now we are building upon multiples, powers, and factors to look at prime factors, HCF, and LCM. So the topic for this video is prime factors, HCF, and LCM. These are very useful topics, especially when it comes to handling fractions, okay? And it's not just the basic fractions that we do in primary school, like if I give you 2/7 plus 3/8, okay? This is indeed useful for solving fractions like this, HCF and LCM. But you will soon realize that when we start looking at other topics such as algebra, there is a very stubborn topic in algebra called algebraic fractions. And they can torment secondary school maths students somehow, okay, high school maths students. So when we understand how to handle fractions, we will find algebraic fractions a breeze through. Okay, we will solve it without sweat. If we don't understand the basics in handling fractions, we will struggle when we come further into these more complex topics. And so I'm taking my time to explain how we do that. And for us to get a detailed understanding of handling fractions like these, operations with fractions, we need to master HCF and LCM. And then they go hand in hand with prime factors. We use prime factors to work out HCF and LCM. So I'm going to begin this lesson looking at prime factors, and then we will move on to HCF and then LCM. Now, what are prime factors? Prime factors are very useful when we are working at the basics of mathematics. But before we go on to prime factors, what are prime numbers? Prime numbers. What are prime numbers? We've already looked at factors, right? We looked at factors in the third lesson when we were looking at multiples, factors, and so on. Powers and roots. Now, prime numbers. What are prime numbers? We know prime numbers from primary school. They are numbers that have only two factors. Numbers that have only two factors. Okay, they don't have any more factors. And those two factors are actually themselves and one. Only two factors. And what are those two factors? Themselves and one. of course, 1 permeates everywhere in mathematics. So it's not surprising that prime numbers have 1 as their factor. Okay, if you multiply anything by 1, you've technically not done anything to it. Okay, but strictly speaking, a prime number is a number that has only 2 factors. And these 2 factors are the number itself and 1. So a classical prime number is 2. Okay, and it's a very tricky thing. Okay, because when we were doing primary school mathematics, it almost felt like all prime numbers were odd numbers. Okay, we know even numbers and odd numbers from primary school when we start handling numbers in mathematics, when we start understanding counting and simple addition and subtraction. At that point, we looked at odd numbers and even numbers. But for some reason, we felt that all prime numbers were odd numbers. But that is not true. And a very typical example is 2. 2 is a prime number, okay? And I've often seen students omitting 2 when they are asked to list the first 5 prime numbers. So you ask students to list the first 5 prime numbers, and they are likely to go 1, 3, 5, 7, 11. Okay, but that is not quite right. Okay, first of all, let me make something clear. 1 is not a prime number. 1 is not a prime number. 1 is a very strange number in mathematics. But for this topic, just get it clear. 1 is not a prime number. Okay. Secondly, 2 is an even number. Normally, the even numbers are very easy to handle. They will have something to divide into it, right? At least every even number will have 2 dividing into it. So 2 being an even number doesn't readily come to mind when we are talking about prime numbers. But today, I want you to understand that you will have to replace 1, which we have long held as a prime number, with 2, which we often ignore as a prime number. So when I ask you to list a set of the first 5 prime numbers, you are going to have 2, 3, 5, 7, and 11. These are the first 5 prime numbers. 1 is not a prime number, 0 is not a prime number, 2 is a prime number, and then subsequently, numbers that cannot be divided by any other number apart from themselves and 1, they will make our set of prime numbers. So now we know what prime numbers are. Now that we know what prime numbers are, let's go on to what prime factors are. We learned about factors in the previous lesson. We've learned about what prime numbers are. So prime factors, we will combine the two. They are simply factors that are prime numbers. Yeah. Factors that are prime numbers. Okay. Factors of any number that are prime numbers as well. Now, why is it such a big deal to be talking about prime factors? It's simple. When you have any number, when you have any big number, let's say 12, if you get the prime factors of 12, then it means that you've gone to the very base of that number, because once you hit a prime number, you can't go any further below that, because you won't have anything more dividing into that number. You've hit the baseline, so to speak. So they are very important. So when we want to know more about any big number at all, getting to their prime numbers give a lot of information. And that is why we use prime factors a lot when we are talking about LCM and HCF. So how do we find prime numbers of any number? It's very simple. We use what we call the factor tree. Okay, the factor tree. Now, the factor tree is very interesting, and we did that a lot when we were starting out in maths in primary school. Okay, it's very useful. So let's say I have 24. Okay, I'll keep breaking them down until I cannot break down a number. Okay, until I cannot break down a number except by itself and 1. Then I know that I've hit the prime factor. Okay. Normally, when you have an even number like 24, it's good to start with 2. Okay. It's good to start with the smallest even number, 2, and keep breaking it. Okay, so 2 itself is a prime number, so you already have one prime number on the side. But you keep breaking them, and so long as it's even number, keep breaking it with 2, because that is the surest way of getting to the barest minimum. So I will bring 2 again, and that gives me 6. I will bring 2 again, and that gives me 3. So now, if I collect all the prime numbers and multiply them, they should give me the prime factors of the number. So prime factors of 24 are 2 times 2 times 2 times 3. Or I can tidy this up and simply say 2 to the power 3 times 3. And if I want to be sure I'm correct, let's analyze this arithmetically. 2 to the power 3 is 8. 8 times 3 is 24. And that is the number that I began with. Okay. But what will help me is that once I know the prime factors, I can easily use that to establish what my HCF is and my LCM is. And we'll be looking at that in a minute. Okay. Now let's look at another number, which is not an even number and it's not divisible by 2. So it will be wise to start with the next big number right after 2, which is 3. And hopefully 3 should be able to divide into that. So I'm going to do 3 and 9. 9, 2 cannot go into 8, so I'll try the next big number, which is 3. And then I have it. So the prime factors of 27 are 3, 3, and 3, or simply 3 to the power 3. So that is how we find the prime factors. The factor tree. My advice is that start with 2. If the number is not an even number, then start with 3. Keep using these 2 numbers until you really can't use them. Then go on to the next number, 3. Then go on to the next number, 4 and 5. So for instance, let's try another example. 75. 75. I want to introduce something. 75 is not an even number, so I probably won't have any luck when I use 2. So let me try 3. Okay. 3 and 25 will be factors of 75. So now I'm going on to 5. 25 is not an even number, so 2 won't work. Let me try 3. 3 won't work. Let me try 4. 4 won't work. The least number that will work is 5. So let me do it. But strangely, 5 and 5 exhaust all of them. And 5 and 5 themselves are prime numbers. So I've come to the end of my prime factors. So the prime factors of 75 then becomes 3, 5, and 5. And when I multiply them, I get a 75. So I can tidy it up and say 3 times 5 to the power 2. And that is it. Okay, so that is how you will find prime numbers. Look out for the number. Start by dividing into that number with the smallest possible number. If it is an even number, then definitely start with 2 and keep going in 2 until you exhaust everything. If it's not an even number, then try 3. If 3 works, then carry on dividing with 3. If 3 doesn't work, go on to 4, go on to 5, go on to 6, go on to 7, and so on and so forth. There are some numbers you may have to start with 7 because 2 will not divide into it, 3 will not divide into it, 4, 5, 6 will not divide into it, except 7. So for instance, if I give you 49 and I tell you to find the prime factors, you will have to definitely start with 7 and keep dividing into it until you have exhausted all the numbers. So that is prime factors. That's how we find prime factors. Now let's go on to HCF. HCF. What is HCF? HCF is simply highest common factor. And what is the purpose of highest common factor in mathematics? Or what is the use of highest common factor in mathematics? Let me pause here and give you a minute to gather your thoughts and see if you can tell me anything why HCF is even done in mathematics. Okay? So take a break, think about it, and let's continue the video. So in maths, HCF is very useful for 2 things. 1, sharing things equally across 2 numbers. You find HCF being very useful. And then secondly, one of the things that makes HCF very useful is simplifying fractions. Simplifying fractions. And that is very necessary because when you are normally working a problem in maths, we expect that as a good student of mathematics, you will keep your answers always at the simplest form of a fraction. So for instance, you are finding the probability of something and you end up getting 20 over 60. Although 20 over 60 is a correct answer, we will expect that you will keep it to the simplest form, which is 1 over 3. Now, how do I get the 1 over 3 easily? If I know the HCF of 20 and 60, I will just divide both by the HCF and straight away I'll get my simplest form of the fraction. Now, it's very important that we develop the habit of keeping our final answers in the simplest forms as possible because some of the marking schemes of certain math questions have additional marks for giving a more matured answer. And so when you work out a problem and you have a final answer, let's say 8 over 24, we will expect that you will keep this to the simplest fraction. And for you to easily do that, you will need to know the HCF of it. So that is it. The other way of sharing things across things equally is the same thing as simplifying fraction. You want to distribute something over two groups of people. How many will each group get? If you know the HCF, it becomes very easy for you to determine how many each of the group can get. Okay, so these are the applications of HCF. Now, how do we find HCF? So we've already defined HCF as the highest common factor. So how do we find it? It's very simple. You will normally find the highest common factor of two or more numbers. So I can give you 12, 24, and 36. And then I'll tell you to find the HCF. Okay. It can even be more numbers, but typically, from experience, when you are doing a maths exam, it begins with easy questions. It begins with the fundamental knowledge questions, and you could be asked to find the HCF of a set of numbers. Typically, they'll give you two, maximum three. But don't be surprised if you have 4 or 5 numbers and you are asked to find a common factor. The principle is the same, the procedure is the same. All what you need to do is to start listing all the factors, not the prime factors necessarily, but all the factors. Okay, so we have looked at working out factors. We will prime factors. We will now look at working out factors. Okay, you can still use prime factors to find factors. Okay, and let's get this clear. The factors of any number are not only prime factors. Prime factors is another concept. Prime factors is another concept, but numbers have factors, and some of the factors will not necessarily be prime numbers. When you are looking for the highest common factor, because you are looking for the biggest factor that is common to all the numbers, you may not necessarily be dealing with prime factors. You may be getting different factors because your highest common factor will likely not be a prime factor, okay, depending on the set of numbers you have been given. So before we come to this, let's quickly see how we can find the factors of any number. We can still use the prime factor tree, and then we will multiply the different prime factors that we get to get the subsequent factors. So let's use 24. Let's use 24. And let's start finding the prime factors. So 2, 12, 2, 6, 2, 3. Okay, so these are the prime factors. These are the prime factors. Oh, no, not 6. These are the prime factors. Now, all the factors of 24 are the numbers that, the whole numbers that can multiply something to give us 24. Okay, so already we have the prime factors, but they are not all the factors. Okay, they are just what will multiply to give us that. But in addition to the prime factors, we can see some numbers that can be multiplied to give us the 24. We can see some numbers that can be multiplied to give us the 24. Okay, so how do we find all the factors of 24 now that we have the prime factors? It's simple. We can multiply some of the prime factors to generate another kind of factors that are not obvious in this factor tree. So, for instance, 2 times 2 can give me 4. And 4 is also a factor of 24, but 4 is not necessarily here, right? But 4 multiplies 6 to give us 24. So 4 is a factor. Now, if 4 is a factor, 2 and 4 can also give me 8. Okay? And 8 wasn't necessarily in here because of the approach that we took. But 2 and 4 will give me 8. So whenever you make the prime factors, first look at the skeleton. All the big numbers that you broke further to get your prime factors, they will be included as the factors. But in addition, try multiplying the prime factors with each other to see if you can get numbers that are not in the structure, in the tree structure. And once you can get them and you can find a number that it can multiply to give you the big number, they also become factors. So now we've broken down 24 as far as we can go. So we are now going to list out the unique numbers. Okay. A factor is a factor. If you have 2 and 2 and 2, you don't really need to list all the 2 because you are not finding the product of the number. You are just listing its factors. So they may not necessarily multiply to give you the number, but they are represented. So I can see 2, I can see 3, I can see 4, I can see 6, I can see 8, I can see 12, and then, of course, 24 is also a factor of 24. And then, of course, don't forget our good old 1. Okay, so we've listed all the factors of 24. Can I leave you to try out doing getting the factors for 36? Can you pause the video and list out the factors of 36 using the same method that I have done? The clock is starting now. Give yourself 1 minute. No, okay, 2 minutes and list out the factors of 36. Okay, welcome back. So let's see what you got. Let's see what you got. 36. Of course, it's an even number, so I will start with 2. 18. I'll go with 2 again. 9. I'll go with 3. 3. And then I'm done. Okay, so we can see some obvious factors in the structure, but these are not all. Why? Because we need to try out multiplying some of the prime factors to generate more. So 2 and 2, 4. 4 is also a factor of 36. 2 and 3, 6. 6 is also a factor of 36. Okay. And then, of course, 4 and 2, 8. 8 is not, because there's no direct number that can be multiplied by 8 to give us 36. So I'm just making sure we've exhausted all possible numbers. So now the factors of 36, we can list them as 1, of course. We got 2 there. We got 3 there. We got 4. We got 6. We got 9, 18, and of course 36. 36 features. There can also be another. We are missing 1. We are missing 1. 2 and 6. 12. 12 is another one. 12 is another one. Okay, so when you really need to get the factors of a number, you really need to inspect it closely and make sure that all the prime factors are multiplying to give slightly bigger numbers, but check that those bigger numbers can be can divide exactly into the big number you are finding its factors, so that you can make sure that you always capture everything, because the one that you may omit may actually be the HCF that you are looking for. Okay, the one that you may omit may be the HCF you are looking for. So make sure you capture everything. Okay, so we have 24, we have 12. Then, of course, let's quickly do 12. So 12, 2, 6, 2, 3, 2 and 2, 4. And I think that is all there is. So for 12, we have 1, 2, 3, 4, 6, and 12. Okay, so now we've listed all the factors. Now, how do we find the highest common factor? It's simple. Okay, literally, the highest number that is common to this, that, and that. So we will inspect them. We will inspect them. I can see 12 here. I can see 12 here. 18 is bigger than 12, but I don't see 18 here. So, and I can see 12 here. So it tells me that the HCF for 12, 24, and 3 is actually 12. It's 12. It's 12. Okay, it's 12. That's how you find the highest common factor. Okay, so for instance, if I had a fraction like that, 24 over 36, maybe I worked out a probability question and my final answer was 24 over 6. Knowing that the HCF of this is 12, I can divide both numbers by 12. This goes here 2, this goes here 3. And I can keep my final answer as 2 over 3, which will be a more matured answer. Okay, a more matured answer. Now, if I were sharing a number of items across groups of 24 and 36, then I know that if 12 is a number I should be looking for, I can make sure that 12 will go into 24 and 36. So if I'm seeing ways of sharing things across groups of different numbers, I can be thinking of the highest common factor. And that can give me a tip on what exactly I should be considering, giving them what number I should be considering. So that is how we find HCF. As I said, it's very important when we are simplifying fractions, which is a very useful skill in mathematics. But it's also useful when we are trying to share a number of items across different group of numbers. So there you have HCF. Now let's go to LCM. Let's go to LCM. LCM stands for the least common multiple. In a way, it feels like the opposite of HCF, because here least and here we are talking of highest. Okay, so opposite. And then the common is the common, because you want the common multiple across a range of numbers. Then the multiple is factors. Again, when we were looking at multiples and factors, we found out that the exact opposite of a multiple is factor. So the LCM and the HCF kind of are opposite, but not directly opposite, because they take different procedures to arrive at each of them. But LCM is very useful. And what is the purpose of LCM in mathematics? LCM is very useful when we are adding or subtracting fractions. Okay, so adding or subtracting fractions. And as I told you, it's okay if we can do simple addition and subtraction of fractions like 2 over 7 minus 1 over 18. It's okay when we can do things like this. But if we understand the concept of manipulating fractions, whether adding them, subtracting them, we can carry that skill into what we call algebraic fractions, which can become very complicated and often pose a lot of problems to secondary school and high school mathematics students. So it's very important that we get the basis here. And for us to master the manipulation of fractions in terms of adding them, subtracting them, least common multiple is a very useful skill that we can use to arrive at that. So let's look at least common multiple, LCM. How do we find LCM? It's very simple. Again, we can do it easily by listing out the multiples of the two or more numbers we've been asked to find their LCM, and then inspecting it to see which one is the smallest among them. Which one is the smallest common one among them? So again, let me use the same numbers that I used for 12, 24, and 36. Let me first start by listing the common, the multiples of 12. So I can have 12, of course, because 12 times 1 is 12, and that's a multiple of 12. By 2, 24. By 3, 36. By 4, 48. By 5, 60. By 6, 72. Let me leave it here for now. Perhaps I may not need to go further than that. Now let me come to 24. 24 times 1, of course. So 24 is a multiple. 48. 72. 96. Let me leave it there for now. 36. 36, of course. 36 times 1. 72. 108. Let me leave it there. So already, I've seen some common multiples. But are they common to all of them? So inspecting this, I've seen a common multiple of this and that here. I've seen this and that here. But which one is the least that I can find across all three numbers? It looks to me like 72 is featuring in all three. And that is the smallest number that I could find in all three. So the LCM for 12, 24, and 36 becomes 72. Okay. And if I were working in a fraction, if I were adding fraction or subtracting fraction, and for instance, the denominators had 12, 24, and 36, then I could be using 72 as the LCM to help me to add or subtract the fractions. Okay. Now, listing is very easy. Listing fractions, listing the multiples to find the LCM is very easy. But how about when you are given a slightly bigger number? When you are given a slightly bigger number, and especially you are doing a non-calculator paper, because depending on where you are, you can have a section of your maths final exam requiring that you do not use a calculator. If that is the case and you are meant to find the least common multiple of slightly bigger numbers, it can be challenging. So there is an advanced way of finding the least common multiple. There is an advanced way of finding a least common multiple. And let's go and check that out. So, for instance, I give you numbers like 108 and 120 to find their LCM. 108 and 120 to find their LCM. How are you going to go about it? are you going to start working out the multiples of these big numbers? That will be very difficult to do. Okay, so let's look at another advanced way of finding LCM. And this is particularly useful when you are finding LCM of big numbers. Okay, so we have 108 and we have 120, and we are to find its LCM. Typically, you will want to set out finding the multiple. So 108, 216, and so on. But the numbers become very big so soon, and you may keep going and going, and it can waste your time. It can waste your time, especially when you are in a time constrained exam where you are expected to answer a number of questions in a specific time frame. Okay, you couldn't be going on and so on. The 120 is pretty much easy, but the 108, you may spend time trying to find the multiples until you get a common multiple. So there is a clever way, a more advanced but clever way of doing this. And what you need to do is to find the prime factors of each. Find the prime factors of each. So let's go 108. Let's start finding the prime factors. Remember, this is an even number, so I will go with 2. So there I have all my prime factors. Let me circle them for them to stand out. Okay, and if I want to check, I can do 3 times 3, 9, 9, 3, 27, 27 times 2, 54, 52 times 2, 108. Okay, good. Now, let me do the same for 120, 120. Again, even number, so I'm trying out 2. So there I have my prime numbers. So now I have to list out all my prime numbers for each. I have to list out all my prime factors for each. So this one becomes 2 to the power 2, isn't it? 2 to the power 2 times 3 to the power 3. Okay, so that is what I have for 108. 2 to the power 2 times 3 to the power 3. That's what I have for the 108. How about the 120? The blue team. I have 2 to the power 3 times 3, or 3 to the power 1, or just simply 3 times 5, isn't it? Okay, so here is the trick. Now that we have our prime factors making up each number, we are going to look at both of them and select the common numbers from each group, but the one with the highest number. The one with the highest number. Okay, listen to this carefully. If you miss this point, you will not be able to apply this trick to finding the LCM of bigger numbers. But this trick can be very useful, especially when you have to do this thing quickly. So I have 2 here. It is 2 to the power 2, but I have 2 to the power 3 here. So I'm going to settle for that. Okay, I'm just looking at the common numbers, and then I'm selecting the one with the highest powers. The highest powers. So although I have 2 to the power 2 here, I have 2 to the power 3. So I'm going to ignore this one and select this. So I have 2 to the power 3. Okay. Then here I have 3 to the power 3, and here I have 3. So I'm going to ignore this one and select this one. Okay, I'm just looking for the common number prime factors, but the ones with the highest power. So I'm getting 3 to the power 3 here. And then 5 is not common, so 5 must come with me. Okay, if you have anything that is not common to both, that one must come. So my LCM is actually going to be a product of these numbers that I've selected from the 2 sets of prime factors. And when I multiply these together, I am going to get the LCM for these 2 numbers. And you will see how big that number is, and you can now understand why it may have taken us forever to try and figure out multiples until we meet a common one. So 2 to the power 3 is 8. 3 to the power 3 is 27. 3 times 3, 9. 9 times 3, 27. And then this times 5. So what I'm going to do is, it's easy to multiply that. I'm assuming this is a non-calculator paper. It's easy to multiply that. So I'm getting 40 times 27. Okay. I'll quickly multiply 27 by 4. And I get 108. So this become 1080. So the LCM for this number and that number is 1080. So I should have actually listed multiples up to 1080 before I would have found a common one. But going through this procedure, I've quickly found out what my LCM is by not using any calculator at all. If I don't use a calculator, I can't hardly go beyond the 4th multiple of 108 because it's such a big number and I have to keep working things out, and that could be time wasting. So instead, we use this advanced way. Now, one of the main objective is to provide very concise, straight to the point lessons so that you can have a lot in a short time of having to watch our videos. So I'm not going to do another example, but I'm going to leave you with one for you to try. Find the answer. Use this particular method. I know you can quickly use a calculator to find the multiples until you get a common multiple and find the least one. But no, try this one so that in future, if you are in an exam and you are having to find the LCM of slightly bigger numbers, you will be able to use this method and save yourself some time and bank in all the marks that is allocated. So I'm going to give you an example. You try it, and for those of you who would do it, put your answer in the comment and tell me if you really use this method and why, and see if it is really something you could be applying to in your exam. So find the LCM. This is for you to do. Get your paper and pens. Find the LCM of find the LCM of 78 and 90. Find the LCM of 78 and 90. Use the advanced procedure like finding the prime factors and selecting the common prime factors with the highest powers. Use that one to solve this problem. And I'm curious to know what answers you guys come up with. So you can pause the video, do it now, get your answer, and drop it in the comment. And then we will see what the answer was. Thank you very much. We will bring this lesson to an end here. But where are we going next? Where are we going next? We have been looking at number, and we have already done in this set of lessons, types of numbers, board mass. We've done multiples, factors, powers, and roots. And we have just completed prime factors, HCF and LCM. In our next lesson, we will be looking at fractions, decimals, and percentages. And all these are about competency in manipulating numbers, because when it comes to solving complex problems where multi-step approach is required, we will be in a very good position if we can easily convert fractions to decimals to percentages and so on. We can basically handle the numbers and manipulate them in a way that fits our objective. So that is the next topic that we'll be looking at: fractions, decimals, and percentages. And then we will be gradually coming to the end of the part 1 of our major topic, mass. Thank you, and see you in the next lesson.